Hello everyone. So today we'll be doing ocean bottom relief as a part of oceanography. Now, before dealing with the ocean bottom relief, let's first discuss the brief about different oceans. 71% of Earth's surface is covered by hydrosphere, and remaining 29% is covered by lithosphere. And the origin of ocean lies in this volcanic degassing of water vapor from Earth's interior. Now, what happened during this primordial Earth? Earth was initially like a hot molten ball from where a number of volcanic eruptions took place, and that led to degassing of water vapor, which further led to formation of clouds, and then it led to form this rainfall over the Earth's surface. That led to formation of oceans that covers 71% of Earth's surface. Now, it is said that some small amount of water may have come from comets that hit the Earth. Then the average depth of ocean is 3,800 meter, and the average height of lithosphere is 840 meter. Okay, now there are total five oceans. You can see here the first one, Pacific Ocean. This is the largest ocean. Atlantic Ocean, Indian Ocean, Arctic Ocean, and the fifth one is the Southern Ocean. These are the different depths of five oceans. Now, these reliefs we'll be covering today: continental shelf, slope, rise, abyssal plain, trenches, submarine canyons, seamounts, and guyouts. But how do we study the relief feature? Now, see, in order to study the seafloor or relief features of ocean, we use the technology of sonar, that is sound navigation and ranging. Now, in this, sound waves are emitted from the ships and they are received by the sensor. Now, sound waves, the speed of sound waves we already know, and the time actually taken from for these sound waves to reach the ship is calculated, and accordingly the relief of ocean basin is calculated, right? So, moving on to the features of the seafloor. See, there are two types of continental margins. One is passive continental margin, where there is generally no tectonic activity going on. And in these types of continental margins, there will be a continental shelf, a continental slope, and continental rise. And then there will be a abyssal plain. But in those continental margins which are active, that means there is any tectonic activity which is taking place, these kinds of continental margins will have continental shelf, slopes, and there will be a deep oceanic trench. Now you can see here, this one is the shelf, then this is slope, then continental rise, abyssal plain. These are the trenches along the active continental margins, right? This one is the abyssal plain. Okay, so we'll discuss each in detail. Now, the continental shelves and slope. The first one, continental shelves, these are gently sloping 1 to 3 degree. They are seaward sloping, right? And these are shallow submarine platforms at the edges of continents. You can see it here. These are shallow continental shelf. Okay, this is gradually sloping, and their range may vary from few kilometers to 500 kilometers. They are covered with young sediments. For example, the continental shelf around KG Basin in India, the continental shelf around Mississippi River, at the mouth of Mississippi River in Gulf of Mexico, right? It covers around 8.6% of total area of ocean basins. Now, moving on to the next one, that is continental slope. You can see it here. This is actually steep. They have relatively steep slope, typically 5 to 60 degree, right? And they extend from the edge of continental shelf, right after the continental shelf, this continental slope starts, and it has very steep slope. It covers 8.5% of total area of ocean basins, and the depth of water over continental slope may vary from 200 meter to 2000 meter. Okay, so the next feature is submarine canyons. Now these are actually found in the continental shelf and the slopes. These are V-shaped valleys that run across these continental shelf and down the continental slopes. Generally, these submarine canyons are found along the mouth of the river. For example, the canyons around this mouth of Mississippi River, or around Nile River or Amazon River, right? And these deliver continental sediments to abyssal fans on deep sea floor. Now see, this one is the deep sea floor. This is the continental sediments, right? This is known as abyssal fan, and this V-shaped valley is submarine canyon. Okay, so the next one is continental rise. Now this is actually a transitional zone between continental and oceanic crust. You can see here, this is the transitional zone. After this continental rise, the oceanic crust starts, right? And the sediments are deposited here just at the base of continental slope. There is this continental rise. The slope is less than 0.5 degree. Okay, the next one is the abyssal plain. You can see here, continental shelf, slope, continental rise, and from here abyssal plain starts. Just after continental rise, abyssal plain starts, and it is extremely flat region beyond the base of continental rise, flattest features on earth with slope of less than 0.01 degree. Okay, So the next one is oceanic trenches. As we discussed that along the active continental margins, these oceanic trenches will be found. Now these are narrow, deep trough parallel to the edge of continent or an island arc. Now you can see here wherever a heavy plate will subduct below the lighter plate, oceanic trenches will be found, and these are the deepest parts of ocean. You might have heard of Mariana Trench. You can see it here. Here is the Mariana Trench where the Pacific plate is subducting. Pacific plate is a heavier plate, right? It is subducting below a continental plate. These are all trenches you can see here. These are all along the convergent plate boundaries. Java Trench, Mariana Trench, Aleutian Trench, Kuril and Japan Trench, right? So this is the world distribution of trenches. The next one, this is the Mid-Oceanic Ridge. Now see, Mid-Oceanic Ridge, these are giant undersea mountain range. It extends around the world. You might have heard of Mid-Atlantic Ridge. Now these Mid-Oceanic ridges are found along the divergent plate boundaries. Why? Because mostly the young basaltic magma, or you can say there is upwelling of magma along the divergent plate boundaries, and due to this there is this basaltic flow which forms these mid-oceanic ridges. Okay, and here generally shallow focus earthquake occur and fissure type volcanic eruption occur. Okay, and these are often marked by line of hot springs and geysers. Now see, you can see it here. This one is the mid-Atlantic ridge, and actually Iceland, which is an island, it is a part of mid-Atlantic ridge, and that is why it is famous for hot springs and geysers, right? This is another oceanic ridge. In the Indian Ocean also there is this mid-oceanic ridge. Okay, this shows the upwelling of magma along the divergent plate boundaries. Now, these two plate boundaries are moving apart, and there is this upwelling of magma. This is the basalt flow, and that leads to the formation of mid-oceanic ridge. Okay, the last feature related to oceanic relief is seamounts and guyouts. Now, these are volcanic hills and they are undersea mountains. For example, seamounts, you can see it here, they will be conical at the top. Conical undersea mountains that rise greater than 1000 meter above the sea floor, and these are called seamounts, right? Then volcanic islands, if they move above this sea level, then they will lead to the formation of a volcanic island. If the top is eroded and if it is flat top, you can see it here, guyouts are flat topped seamounts apparently cut by wave action due to the continuous erosion. There is the top is actually eroded, and it leads to flat topped seamounts, that is known as guyouts. Thank you.